morning, students. Today we will be discussing three terms: heat capacity, specific heat capacity, and molar heat capacity. Last class we have discussed how to calculate Q, that is quantity of heat that is to be supplied or to be removed. And this Q calculation we are dividing into two parts. One is sensible heat calculations and the other is latent heat calculations. Sensible heat calculations means when there is no phase change. That means initially, for example, water at 30 is heated to water at 50 degrees centigrade. That is sensible heat. Initially at 30 also liquid form, at 50 also liquid form. So in case of sensible heat calculation, we use the equation Q is equal to m CPM dt. So that heat capacity or specific heat capacity, these terms we need to understand and need to calculate when we want to calculate Q, that is heat energy, in case of sensible heat calculations. So next class we will start calculating this CPM calculation and Q calculation. Now first in this class we will understand the terms heat capacity. What is the difference between heat capacity, specific heat capacity, molar heat capacity? So here, heat capacity is the amount of heat required to raise the temperature of a substance by 1 degree Celsius, also called thermal capacity. That means heat capacity term we use when we want to consider the entire mass of the substance. For example, suppose here 1 liter of water is there, and here 5 liters of water, and here 10 liters of water. So to heat or to raise the temperature of 1 liter of water by 1 degree Celsius, that is example from 40 degrees centigrade to 41 degrees centigrade, only 1 degree centigrade, what amount of heat is to be supplied? That is heat capacity. You take this example. Here 5 liters of water. That means suppose this is at 30 degrees centigrade. And in order to increase this temperature to 31 degrees centigrade, difference is only 1 degree centigrade. And to heat the entire 5 liters of water, entire 5 liters, that is the difference. We don't consider weight or volume separately. So entire 5 liters of water through 1 degree centigrade, what amount of heat is to be supplied? Similarly, here also 10 liters. Suppose this is also 30 degrees centigrade. We need to heat to 31 degrees centigrade. Only 1 degree centigrade difference. To raise the temperature of this complete 10 liters of water, what amount of heat is to be supplied? That is called heat capacity. The term capacity itself is explaining us the capacity it is. So that is the term heat capacity. Therefore its units are what? Joules per kg. Kelvin. Joules per Kelvin. Kilocalories per Kelvin, etc. Any energy per Kelvin it is. In the denominator I already explained you, 1 degree denominator, 1 degree Kelvin equal to 1 degree centigrade. So either Kelvin or centigrade, that is not a problem. Okay, so joules per Kelvin, kilocalorie, what amount of joules is required to raise the temperature of 1 Kelvin or by 1 degree centigrade. So it depends on the mass of the substance. Here 5 liters means if it is CP is 1, 5 joules are required, like that. Here if mass is increased, more quantity of heat is to be supplied. So it depends upon the mass of the substance. That is, it is extensive property. Its units are like this. Next, specific heat capacity. What is meant by specific heat capacity? Specific, we are adding term specific. to this heat capacity term, isn't it? Heat capacity already we have discussed, and we are adding the term specific. Normally specific means what? As you know, specific term we use per unit mass. Specific term we use unit mass. See, you know the term specific volume. Specific volume is equal to volume per unit mass. You know this term, isn't it? Mass per unit volume is density. So volume per unit mass means inverse of the density. Specific volume is nothing but inverse of the density. So the word specific is per unit mass. So how can you define now specific heat capacity? Heat capacity per unit mass. In simple words you can say heat capacity per unit mass is, see here you can see heat capacity is equal to mass into specific heat. So specific heat is equal to heat capacity per unit mass. Okay, this is specific heat. So that means in the definition it is the amount of heat required to raise the temperature of unit mass. This is important, to raise the temperature of unit mass of the substance. Here we are not saying unit mass, the whole amount, heat capacity. Specific heat capacity is only unit mass, say 1 kg or 1 gram, like that. So unit mass of the substance by 1 degree. Here also 1 degree only. Here also 1 degree only of the substance. Because it is independent of mass, then per kg we are saying, no? So per kg or per gram. So it doesn't depend upon the mass. That is why it is intensive property. So what are the units? Joules per Kelvin is heat capacity per unit mass kg. That means units are very advantageous to understand the concepts also. Very helpful here. See, from unit you can write the complete definition, you can write. On just seeing the unit you can write this sentence. Okay. Joules per kg per Kelvin. That means the joules is heat, the amount of heat required to raise the temperature of 1 kg of the fluid or solid, whatever it is, to 1 kg of the substance by 1 degree Kelvin. That is specific heat capacity or kilocalories per kg per Kelvin. So units, from units you can heat capacity, suppose here we will see these units. What is heat capacity units? Say joules per Kelvin, okay, equal to mass is kg and specific heat capacity is joules per kg per Kelvin, okay. Specific heat capacity. So kg gets cancelled, joules per Kelvin, joules per Kelvin. So heat capacity is nothing but mass into specific heat capacity, or specific heat is equal to heat capacity by mass. So and another 2-3 points we will discuss about specific heat capacity. And normally in these calculations we use the term specific heat capacity only, not heat capacity, because per kg if you know, then for any amount you can calculate. For example, if you go to a shop, okay, you want to purchase onions, then what you will ask the shopkeeper, or the shopkeeper will tell you what is the cost of 1 kg of onions, isn't it? He will not tell you for a 5 kg this much, for 10 kg this much, or for 15 kg this much, like that. Okay, he will tell only per kg. So that if you want to buy for 50 kg, 20 kg, we multiply with that. In the same way, so which property is more advantageous in calculations and given noted down in data books, chemical engineering data books, heat transfer data books, specific heat capacities of all different materials, liquids, gases, solids, all are given at different temperatures. So usually specific heat capacity is very advantageous property. It is the property. Okay, specific heat capacity is an important property. Okay, an important property of the substance. An important property of the substance. Why it is an important property of the substance? For example, we take example values of specific heat capacity. Say water value is 4.19 kilojoules per kg per Kelvin, and oil, coconut oil, it is coconut oil is 2.1 same units, or castor or olive oil is 1.97, like that. These are for liquids. Some liquids it is noted down. And copper solids, if we'll say, for copper, silver, we will take the example, aluminium 0.385, and here 0.233, and 0.897. And also heat capacity of specific heat capacity of air 1.012, hydrogen 14.3, and oxygen 0.918. Okay, so these are specific heat capacities. Specific heat capacities. Okay, of different materials. Suppose we want to select a material of construction. Then we need to think, is it copper is good or aluminium is good? Then how can we select? So depending upon the specific heat capacity values, we can also select. For example, see here, copper 0.385, aluminium 0.897. What does it mean? To increase the temperature of 1 kg of copper, okay, to increase the temperature of 1 kg of copper, 0.385 kilojoules by 1 degree centigrade, 0.385 kilojoules heat is required here. And here for aluminium, to increase the temperature of 1 kg of aluminium, 0.897 kilojoules of heat is required. What here, for which case more heat is required? Aluminium, more heat is required. That means more quantity of heat is to be supplied in aluminium. And in case of copper, less heat of quantity of heat is to be supplied. That is why, if you recall, in olden days, our ancestors, they used to select copper for heating boilers and all that. For heating water, for domestic purposes, they used to select copper as the material of construction. compared to other materials, because it has got 0.385 less it is. With less amount of heat supplied only, that will get heat fast. Okay, and here liquids, if you compare 4.19 for water, for oils nearly 2. You can notice when you in our kitchen also, if you keep oil on the stove, no, it will get heat very fast compared to water. That means less amount of heat it requires to get to raise the temperature. Okay, so like that, the property, it is very important property which is useful in the selection of materials and all that. So it is a property. Specific heat capacity is an important property of the materials. So it depends upon the nature of the material. Depends on nature of materials. Depends on nature of the materials. Okay, for oil something else, for water something else, like that. So that is specific heat capacity. Next, the third term you need to understand is molar heat capacity. Molar heat capacity. Okay, it is molar heat capacity. This is another term we use. So now after understanding what is meant by heat capacity and specific heat capacity, you can only define what is molar heat capacity. Its units are say joules per kilomole per Kelvin. These are the units. So how can you define? It is the amount of heat required, that is this joules, to raise the temperature of 1 kilomole of the substance. 1 kilomole of the substance by 1 degree Celsius. By 1 degree Celsius. Okay, by 1 degree Celsius. 1 kilomole of substance. That is the amount of heat required. Okay, this is molar heat capacity. Usually in case of gases, only usually I am saying, not every time. In case of gases, we use molar heat capacity. Okay, then in case of liquids, specific heat capacity. Why? Because liquids usually in terms of weight and usually for gases in terms of moles. So these are the three terms we need to understand before working out sensible heat calculation problems. And in addition to these three terms, one more term also we will discuss in next class, that is mean heat capacity. This is molar and then mean heat capacity, that is CPM. Then we start solving the problems. Thank you.